Exercise 6F is looking at us sketching cubic functions in factorised forms. Now, not all the questions in 6X are given to us in factorised form. Some of them we'll have to factorise first. But the general idea is that a cubic function has x to the power of 3, and it can be written in 3 different ways. So x cubed, we know, has a point of inflection, and we saw in 6E what that looks like with different transformations. So one bracket all cubed, so for example x plus 2 all cubed minus 3 just means the highest bracket you have in your question is power of 3, it means it's going to have a point of inflection. So this one would look like at -2, -3 would have a point of inflection like that. So at -2, -3. The other way it might look is if you have one of the brackets is squared and the other bracket is just a linear function. So let's say x plus 3 all squared, x minus 1. And if the bracket is squared, it means it has a turning point at that x value. So the x value that would make that bracket 0 would be -3. So at x equals -3, there's a turning point. And then if it's a linear factor, x minus 1, what x value makes that bracket 0 is +1. So that means it has an x-intercept. So if the bracket is cubed, it's a point of inflection. If the bracket is squared, it's a turning point. And if the bracket is linear, it's an intercept. So when we sketch this one here, at x equals -3 and x equals +1, at -3 we're going to have a turning point, and we know because it's positive, bottom left to top right, so we're going to come up like this, it's going to have a turning point there, come through at +1 and cross the axes there. If the third case, if you have 3 linear factors, x plus 1, x minus 2, x plus 4, for example, then all 3 of those linear factors, just like any other linear factor in the other one, is an x-intercept. So at x equals -1, +2, and -4, so -4, -1, and +2, we're going to have intercepts. So it's going to come up across and loop back around through those 3 values. Okay, keeping that in mind, those general ideas, all the questions from 6F, like I said, if we can get them into factorised form, any of these 3, we can just use that general rule if it's a point of inflection, if it is a turning point or an x-intercept. So let's pick one out together. Let's look at 3E. Now E, y equals 4x cubed minus 8x squared plus 5x minus 1 is expanded form now. So we have to factorise it first, which makes life a little bit more difficult for us. But thankfully, from exercise 6A through to E, we've been loaded up with all the tools we need to factorise this cubic function. So let's get rid of this mess. And if it helps, just remember, point of inflection if it's cubed, turning point if it's squared, and intercept if it's a linear factor. So let's see if we can factorise this. 4x cubed minus 8x squared plus 5x minus 1. Now, to factorise it, we need to find a factor first. So we need to find one of those brackets. The ones we're looking for, we're using the rational root theorem. So we're going to try and sub in values of x, and if we can find a value of x that makes this whole thing equal to 0, we know it's a factor. All right, that's our factor theorem. And the only ones we're going to try is any of the factors of 1 in the numerator and any factors of 4 in the denominator. So factors of 1 are 1, so I'm going to try positive, -1, and if they don't work, I can try factors of 4, or 1, 2, and 4. So I can try 1 over 1, 1 over 1, -1 over 1, which is just positive, -1. The other ones would be a half, or -1/2, or a quarter and -1/4. I always start with 1. So let's use our function notation. Let's call this f of x. So let's try at f equals 1. Let's sub that in. So 4 times 1 cubed minus 8 times 1 squared plus 5 times 1 minus 1. 1 cubed, 1 squared, and 1 to the power 1 are all going to equal 1. So that's why 1 is a nice one to sub in first. So this ends up being 4 minus 8 plus 5 minus 1. 4 minus 8 is negative 4, plus 5 is positive 1, minus 1 is 0. And that is good for us because now we know that x minus 1 is a factor. Okay, the x value, positive 1, would make this bracket 0. So the whole thing here in factorised form would equal 0 if that was a factor. So let's do a quick long division of that. I'm going to use a synthetic method to save time. So let's put all our coefficients: 4, negative 8, 5, negative 1. And we can go through, put a 0 in. This is what we call a synthetic, or the box method, or the cheat method. So I go 4 plus 0 would be 4. So then I go 1 times 4 is 4. Then I add these. I end up getting negative 4. And then when I add these, I get negative 1. So negative 1. What have I done wrong there? 4 plus 0 is 4. Negative 8 plus 4 is negative 4. 5. Oh, that should be positive 1, shouldn't it? So that should be positive 1, and equals 0. Alright, I knew it should have equaled 0. That's how I knew I made a mistake. So that 1 times 1 is 1. Negative 1 plus 1 is 0. So these boxes here are the coefficient when we factorise here. So I could write this as 4x squared minus 4x plus 1. And all of that times x minus 1 would equal what we started with, 4x cubed minus 8x squared plus 5x minus 1. So now we need to factorise this. I'm looking for factors of 4 that add up to negative 4. And I know that is, so positive 4 that add up to negative 4. So it would be negative 2. So 4x squared. I can have minus 2x plus 1. I'm just using grouping now to try and factorise that quadratic. And I end up, I can take out here a factor of 2x. So I'd get 2x outside of 2x minus 1. And over here I can take out the negative 1 and I end up getting 2x minus 1. So I can see I've got the two brackets are the same. X minus 1. So that means this whole original thing here can be written as 2x minus 1 times 2x minus 1, x minus 1, and you go, oh, hang on, these are the same. So our original function is, in factorised form, 2x minus 1 all squared, x minus 1. Okay, squared bracket means we've got a turning point, and the x value in here would be at a half. So let's draw our axes here. At x is a half, 1 on 2, I've got a turning point, and at x is positive 1, I've got an intercept. So I'm going to be coming out from down here, turning around, and then going up through positive 1. So here at a half, 0, and at 1, 0 are my x-intercepts. And the last point that I need to find is this bad boy over here, our y-intercept. So when x is 0, I end up getting negative 1 squared is positive 1 times minus 1 would be negative 1. So that's the point, 0, negative 1 is that intercept. Okay, so to recap, 6f, we're factorising, and you can see we've used the factor theorem. So value of x that makes the whole thing 0 helps us find one linear factor. And then we can use our long division to divide by that linear factor that we just found to find the quadratic that multiplies that linear factor to give us our original cubic. Then we use our stuff from previous in the year to factorise that quadratic. I used grouping here. You could use a range of different methods depending on what you have. You might have difference of two squares. You might have to use quadratic formula if you're not sure. You might get some nasty ones with surds in tech active exams. This one is a nice even sort of numbers at the end. And you could also get an example where this last line here was two different factors. So you end up having 3 intercepts here. It just makes your graph look a little bit different. But once we've used our quadratics to factorise, we can write the whole thing in factorised form, and then we just use each of these brackets to help find the x-intercepts. Are they turning points, are they intercepts, or are they point of inflections? And we follow that general rule. I did mention before, 2x times x is positive. We know at the top here it's positive x cubed. So it's bottom left to top right. If that was a negative up there, it would go the other way.